What is electric current? Flow of charge per unit time. Flow of electrons per unit time. That is, 1 electron is equal to 1.6 into 10 power minus 19 coulomb. SI unit of charge. Q is equal to n into e power minus 1 coulomb is equal to n into 1.6 into 10 power minus 19. N is equal to 6 into 10 power 18 electron. Electric current I is equal to Q by T. Q is equal to IT. Electric current is measured by ammeter. Current SI unit ampere. Charge positive negative. Current is equal to charge per time. Like charges repel each other, opposite charges attract each other. Conductor is a material that conducts electricity, allows electron to flow through it. Potential difference: the amount of work done in moving a unit positive charge from one point to another in a electric field. Positive. The unit SI unit volt. Potential difference SI unit is volt, and charge measured through voltmeter. V is equal to W by Q. V potential difference. W work done to move the charge. Q charge. 1 volt is equal to, if 1 joule of work is done in moving 1 coulomb of charge, 1 volt is equal to 1 joule by 1 coulomb, or 1 C, or 1 charge. Ohm's law by George Simon Ohm in 1827. V increases, I increases. V is equal to IR, resistance. SI unit ohm, Ohm's law. The current flowing in a conductor is directly proportional to the voltage across the conductor, provides all the physical condition and temperature remains constant. Provided all the physical condition and temperature remains constant. Vi, there is a slant line. Higher the slope, higher the resistance. Resistance, the property of a conductor to resist the flow of charge through it. Factors affecting resistance: length, more resistance, more collision of electrons. Area of cross section, more area, less resistance, less collision of electrons. Temperature increases, resistance increases. Nature of temperature, increase momentum of electron and kinetic energy. Nature of material, R is directly proportional to L. R is proportional to 1 by A. R is proportional to L by A. R is equal to rho L by A. Rho is equal rho resistivity or specific resistance. Specific resistance, the resistance of a material is the resistance of a wire of that material is the resistance of a wire of that material. Resistivity is a constant value. Rho is equal to mho by or mho by oh m inverse. Ohm is equal to rho m by m square. That is that is ohm into m is equal to rho SI unit. Conductor, material, resistivity. Ohm meter, silver, resistivity 1.6 into 10 power minus 8. Next, alloys and insulator. Alloys has a greater resistivity than its constituent metals. Types of materials. Conductors. Materials that conduct electricity, allow electric flow through them. Flow. Seen in metals. Has free electrons. Semiconductor. They are materials which have conductivity between conductor and non-conductor or insulator. Example: silicon, usually metalloids. Insulator. Materials that do not allow electricity to pass through them. Example: non-metals such as glass or wood. Resistance of resistance of a system or resistance types. Resistance of a system of resistant types. Parallel and series. Series. R1 connected to R2 connected to R3. Series connection. EQ is equal to R1 plus R2 plus R3 plus R4 so on. And parallel. Same potential difference and different current. R1 connected to see parallel circuit and R2 connected to that circuit and that same circuit and R3 connected to the same circuit. 1 by Req is equal to 1 by R1 plus 1 by R2 plus 1 by R3 so on. Req parallel is less than Req series. Question 2 resistance is equal to 20 ohm and 4 ohm series. 4 ohm in series. Series connected to a 6 volt battery. Current flow is V is equal to IR. VEQ is equal to R1 plus R2. 20 plus 4 is equal to 24 ohm. 6 volt is equal to I into 24 ohm. That is 6 by 4 is equal to I. I is equal to 1 by 4 and 0.2425 A is equal to I. Or uh, when series are connected in parallel. 1 by Req is equal to 1 by R1 plus 1 by R2. That is equal to 1 by 20 plus 1 by 4. 1 plus 5 by 20. 20 is equal to 20 by 6. 6 is equal to I into 20 by 6. I is equal to 36 by 20. That is equal to 9 by 5. Or two resistors connected in parallel. 1 by Req 1 by Req is equal to 20 into 4 by 20 plus 4. That is equal to 80 by 24. That is 10 by 3. And question R1 is equal to 5 ohm, R2 is equal to 10 ohm, R3 is equal to 30 ohm. Parallel conductivity. Potential difference is 12 volts. Current how much? V is equal to IR. 12 is equal to I into 5. 12 by 15 is equal to I. 2.4 A is equal to I. Next V is equal to IR. 12 is equal to I into 10. 1.2 A is equal to I. V is equal to IR. 12 is equal to I into 30. 0.4 A is equal to I. That is 2.4 plus 1.2 plus 0.4 is equal to 4.0 A. Or 1 by Req is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by Req is equal to 1 by 5 plus 1 by 10 plus 1 by 30. Then 1 by Req is equal to 6 plus 3 plus 1 by 30. 1 by Req is equal to 10 by 30. R is equal to 3 ohm. V is equal to IR. 12 is equal to I into 3. Then I is equal to 4 ampere or 4A. Heating effect of electric current by James P. Joule. James P. Joule. V is equal to W by Q. Power is equal to work done by time. Substituting electric current is equal to Q V by T. Electric power is equal to VI. Heat is equal to power into T. Heat is equal to VLT or VIT. IR is equal to IT. I square RT is equal to H. Wheatstone bridge. P by Q is equal to P by R is equal to Q by S. A Wheatstone bridge is a electric circuit used to accurately measure an unknown resistivity by balancing two legs of a bridge circuit. Current from point A pass through P and R, and from B through Q, and from D through S, and joins at C. Battery at E. Practically application of heating effect on electric current. Coils in heater made of nichrome, alloy of nickel and chromium. Filament made of tungsten W has high melting point. Fuse, low melting point. It is used to protect electrical appliances from excessive current and to prevent short circuits or mismatched loads. Short circuits. Current increases sharply. Closed circuit, switch on. Open circuit, switch off. Electric power. P is equal to VI. P is equal to I square R. Or P is equal to V is equal to IR, and P is equal to V square by R, and V by R is equal to I. Kirchhoff law, law of current. It states that he total the total the total current entering a node junction in a circuit is equal to the total current leaving the node. Law of voltage. The sum of all voltages, EMFs and voltage drops around any closed loop. Sigma V is equal to 0 in a circuit is equal to 0. From 1 I1 electricity coming, I3 it is going back, and I2. I1 is equal to I2 plus I3, and electricity coming from I1 and I2 and joining in path of I2, then I1 plus I2 is equal to I3. Commercial unit of energy. 1 unit P into T is equal to 1 kilowatt hour. 1 kilowatt is equal to 1000 watts. 1000 into 3600 seconds. 36 into 10 power 5 watts. And 3.6 3.6 into 10 power 6 joule 1 unit. 1 hour is equal to 60 minutes, that is 60 into 60, 3600 seconds. 220 volts, 50 hertz in electric appliances. Live wire, red, neutral, black, ground or earth, green or yellow. Live wire, very high voltage. Neutral wire, V is equal to 0. Blue neutral, green earth, brown live. Earth complying standard, rated current, rated voltage, line, neutral, live and neutral. These three are color of wire. Calculate the electrical energy conducted by a 1200-watt roaster in 30 minutes. What will be the cost of using the same for 1 month if 1 unit of electric cost rupees 4. 1 unit is equal to 1 kilowatt hour, that is 1200 by 1000 into 30 by 60, that is equal to 6 by 10 into 30 equal to 18 units into 4 equal to rupees 72.